Hey guys, so let's solve that exercise that we started in class, but we didn't have the time to finish. So let's do it right now. Um, so what you have is a particle, like a rock, being thrown from a cliff, right? And this cliff was 30 meters high. Okay. The point from which the rock was thrown is the origin, okay, 0.00, right? And the highest point it reaches has coordinates 12 and 20, all right? So the distance from here to here, we know that this is 12 and this is 20. All right. The key to solve that exercise is to separate the two motions, okay? The vertical motion and the horizontal motion. On the horizontal, well, you don't have any forces acting, right? We are ignoring air resistance. That means that on the horizontal, if there are no forces acting, well, then you have constant motion. And what's the sole equation for constant motion? S equals S naught plus ut. Let's adapt this. We know that the initial position is 0, right, for x. So we're going to have that x is given by the initial velocity in the x direction times time, okay? And this ux is actually the x component of the velocity vector. All right. On the vertical, however, we have accelerated motion. Okay. And what are the equations for accelerated motion? Well, we have that the position is the initial position plus initial velocity times time plus acceleration times time squared over 2. We know that v equals u plus at, and finally v squared equals u squared plus 2a delta s. We can adapt those as well, and they become, well, the initial position y is 0, so the y position is equal to the initial y velocity times time. Well, the acceleration here is due to gravity, the only force acting on that particle, so it's going to be minus 9.8 divided by 2t squared. For the second one, we would get the y velocity equals the initial velocity, vertical velocity, minus 9.8 times time. And finally, we know that the final velocity squared equals the initial velocity in the y direction squared plus, or should I say minus, because the acceleration is negative, minus 2a, so minus 2 times 9.8 times delta y, which is just y. Alright then, so we have two different motions. One in the horizontal, that's a constant motion, constant velocity, and one in the vertical, that's accelerated motion. Alright, what do we know? Let's talk about the vertical motion first. So on the vertical, we know the acceleration. We know that a is minus 9.8 meters per second squared. Alright, we know the highest point, right? We know that, let's call this, if this is a parabola, this is the vertex, right? So the y for the vertex is 20. Alright, that's how high it goes from here, right? And we know that for the vertical motion, when it gets to this point here, the velocity is 0. So let's say the velocity at the vertex is 0. Alright. What equation can we use? We have no information about time. Okay, so no information about time, so we cannot use the first one, nor the second one. But we can use the third one. Alright? The only guy that we don't know here is uy, and we actually want to find out uy. So let's use this one here. So vy squared, well, that's just 0, okay, at this point here, 0 squared equals the initial velocity squared minus 19.6, right? So 19.6 times the height, which is 20. Let's rearrange this so that we have that uy squared equals plus, let's bring out the calculator here, 19.6 times 20, 392. Therefore, uy equals the square root of 392 meters per second. Bring out the calculator again. Square root, so 19.8. So this is 19.8 meters per second. All right, that's the y component for the velocity vector. We don't know the x yet, but that's the y component. Okay, well, now that we have the velocity, we can find out how long it takes to go from the initial point here to the vertex, right? How long does it take to go from the origin to the vertex? Well, again, we're only looking at the vertical motion, all right? And the time it takes is what connects the vertical motion to the horizontal motion, right? It has to be the same time on both, of course, to reach this point here. So I'm just going to erase this so we can calculate it. All right, so now we're going to use this equation here. We know that the velocity at that point is 0, okay, at the vertex. The initial vertical velocity is 19.8. The acceleration is minus 9.8. And now we can find time. All right, so 19.8 is going to be equal to 9.8 times time. Okay, therefore time equals 19.8 divided by 9.8, and this is going to be, calculator, 19.8 divided by 9.8, 2.02 seconds. Okay. 2.02 seconds. That's how long it takes for the particle to go from the origin to this point here. Alright, awesome. But now we can use this time, this information here, to figure out the initial horizontal velocity for the particle. Okay? I'm going to have to erase this. Okay. For the horizontal motion, we only have one equation. Alright? The position, the x position, it's going to be the initial horizontal velocity times time. But now we know both x and t, so we just figure out what ux is, okay? So ux has to be equal to x over time. Right, but x is from 0 to 12. We're talking about the horizontal motion now, so that's 12 over 2.02 seconds. All right, so bring out the calculator. Should be close to 6. 12 divided by 2.02, 5.94. So this is 5.94 meters per second. Okay, so we now have our initial velocity vector. Okay, it's 5.94. I'm just gonna round it to 5.9. So this is the initial velocity vector, 5.9, 19.8 meters per second. Awesome. Now we want to find the coordinates for this point here. Well, y is of course negative 30, right? The origin is here. This point is 30 meters down. So y equals negative 30. So now all we want to find out is this x distance that is traveled. For that, we're going to reference to the vertical motion again. So hope you took notes, but if not, just go back on the video. Let's erase this. We want to remember that time though. Or actually, yeah, actually we don't need it anymore. Okay, so let's start by calculating the time it takes for the rock to go from the highest point to the bottom here, all right? And we're going to do that by using this equation here, okay? We know that y equals uy times time minus 9.8 over 2, that's 4.9 times time squared. So but when it starts here, we know that the velocity, the vertical velocity at the highest point is 0. Okay? So we know that now uy is going to be 0 for the rock dropping from the highest point to the lowest point. Okay? And we know that the initial position, let's call it y0, the initial position is 20. The final position is negative 30. Okay. So the only thing that we don't know is time, so this will suit us really well. We can just cross this. This is 0, and now we do y minus y naught equals minus 4.9 times time squared, right? So this is going to be negative 30 minus 20 equals negative 4.9 times time squared. So negative 50 divided by negative 4.9 is going to be time squared. Okay, therefore time is going to be, calculator, so 50 divided by 4.9, and now take the square root of that, so 3.19. Let's round it to 3.2. Okay, so 3.2 seconds. Right, that's how long it takes for the rock to fall from this point to from the highest point to the bottom. Right, 3.2 seconds. Okay. All right. So what is left? Use this time here to figure out what distance does it go in the horizontal direction. So we want this distance here, and after that we are just gonna add 12 to it. That's gonna be the x coordinate. Okay, let's erase those calculations. So we're looking for the horizontal movement now. Go back to the same equation. We only have one equation for the constant motion. All right, the initial velocity on the horizontal is 5.9 meters per second, right? So this is the equation. So x is going to be equal to 5.9 times 3.2. Okay, calculator. So 5.9 times 3.2, 18.9. Okay, so 18.9 meters. But that's the distance from the x of the vertex to the end. So we have to add 12, right? So it's going to be 18 or 12 12 plus 18.9. Okay, so that's 30.9 meters. Let's complete our point here. So this is point 13.9 and negative 30 meters. All right. Definitely expect 3 or more exercises like this on Saturday. Okay. We're gonna have a lot of fun. All right. See you guys. Have a great late start Thursday, and I'll see you on Friday.